Okay, lesson 1.1 continued. So we were talking about function basics. And so here we're talking about implicit and explicit forms. So it says, when a function is defined by an equation in x and y, we say the function is given implicitly. If it is possible to solve the equation for y in terms of x, such that y is equal to f of x, then we say the function is stated explicitly. The explicit form of a function will be required when using graphing technology. So if I have like 2x plus 3y equals 7, this is considered implicit. Okay, x and y are on the same side. If I have an equation where I've solved for y, such as y equals negative 2/3 x plus 7/3, then this is explicit. This is the form that I could write, or I could type it into my calculator, okay? Explicit form. All right, so let's look at example 3. So example 3 says, given the implicitly defined functions, solve each for y in terms of x. Then state whether the equation represents y as a function of x. So I'm going to take a, and I've got to solve for y first. So let's subtract the 2x. And so we have 3y equals 5 minus 2x. Then we're going to divide everything by 3. And so we get y equals 5/3 minus 2/3 x. All right, so this is in explicit form. We solved it for y, and it wants to know, is that a function? Well, it is a function, and this is actually a linear function. They didn't ask for what type, but I thought you might like to know. All right, B. We're going to do the same thing. Let's solve for y. So I have negative 2y equals 3 minus x squared. And then we're going to divide everything by that negative 2. And so I get y equals negative 3 over 2. And then a negative over negative is a positive. Remember, there's a 1 in front of that x squared, so it'd be 1/2 x squared. Or if you want to, you could write it as 1/2 x squared minus 3 over 2. Either one is correct, okay? And then it asks, is this a function? Well, it's got an x squared there, so yes, this is a quadratic function. All right, look at C. We can solve it for y. So let's divide by the x, because remember it's x times y, and to get rid of it, we always do the opposite. And so we get y equals 1 over x. And that is a rational function. So is it a function? Yes, it's a rational function. And then the last one here, we're going to have to do a little bit of work. So let's move the x squared over. And so I have y squared equals 4 minus x squared. And then to get rid of the square, we're going to take the square root. So square and square root cancel, so we get y equals, remember when you take an even root, you get plus or minus. Now, I know 4 and x squared both have square roots, but because they have that minus sign in between them, they're super glued together, okay? It is a difference of squares, but they're not going to be the same thing in the parentheses, so we're going to leave it as a square root of 4 minus x squared. Now, is that a function? Well, let me tell you that equation is the equation of a circle. So is a circle a function? Well, we haven't talked about it yet. It's coming up in 1.2. But remember a circle, and to see if it's a function, it has to pass that vertical line test. So let me pick some vertical line here. Does it cross in more than one spot? It does. Therefore, it is not a function. Now, notice this is the only one that we had a plus or minus in, okay? So the plus or minus is what makes it not a function. The easiest way to tell if an equation is a function by looking at it is, can you get it to y equals and type it into y1 in your calculator? All right, so let me erase this for just a second here. All right, so can you type it into y1? Can you type equation into y1 equals? If so, function. If not, not a function. Okay, and so we could see, like on C, it was just y equals 1 over x. We could type that into our calculator, y equals. On A, I don't recall right off the top of my head. Let me look at my notes real quick here. The equation came out to be y equals negative 2/3 x plus 5/3. Okay, I think I had 5/3 minus 2/3 x. Same thing. All right, I can type that in y1 and get the whole equation in. On B, we had y equals 1/2 x squared minus 3/2, I believe. And so, yeah, we could type that into y1 as well. But on D, we had that y was equal to plus or minus the square root of 4 minus x squared. Can I type that into y1? Well, do I have a plus or minus button on my calculator? I don't. So the only way we could look at this one is if we typed in y1, let's say we pick one of them, so let's do the negative. And in y2, we have to type in the positive. Therefore, because I had to use y1 and y2 to type that equation into my calculator, it is not a function. All right, let's keep going. So finding the domain of a function. It says if a function f is defined by an equation and no domain is specified, then the domain will be the largest set of real numbers for which the value f of x is a real number. Exclude any real numbers from the function's domain that cause division by 0 or that result in an even root of a negative number that is an imaginary number. So it tells us here to find the domain and the range of each relation below. So look at A. A is just a set of ordered pairs. And remember, domain is your x values, okay? So for the domain, we're just going to list out our x values. And so we have 8, negative 2, 1. We have 8, but I already have it written, so I don't have to write it again. And we have 2. So there's our domain. Our range, remember, is your y values. So I have negative 3, 4, 8, 6, and 7. And so there's our domain and range. On B, same thing, your domain, I'm just going to abbreviate it with a D now here. Your domain is your x values. So look in here and see which x values are used. They're all used. So we have negative 5, 0, 2, and 4. Be careful. Sometimes I'll put extra ones in there, okay? And then your range is the y values that are being used. So we have negative 3, negative 2, and 1. But then on C, they changed it. They gave us a graph, okay? So, again, remember domain is your x's. And your x-axis goes left to right. So you have to look. Does your graph keep going to the left? Yes. Does it keep going to the right? Yes. Now, look in between those endpoints. Is there any open circles, any gaps? Does the graph jump around or anything like that? It does not. So it means it includes every number from negative infinity all the way to positive infinity. Now let me erase this here, because now we're going to look at the range. Now the range, remember, is your y's. Y-axis goes up and down, okay? So we're looking from the bottom to the top. Does your graph keep going down? It does. So it's going to go down to negative infinity. Does it keep going up? No. It has a top point here at 2. So before I put the 2 there, is every point between negative infinity and 2 included? So I can look right here and see that all of those points were included, so yes. So I'm going to go all the way up to 2, and then remember, at the 2, let's look at it there, there's not an open circle or anything, which means 2 is included, and if it's included, we have to use a bracket. So there's our domain and range. And then D. D is just another way of listing a group of ordered pairs. So you could write them out if you need to, or just go across your axis here, okay? Remember, domain is your x's. So as I go across this x-axis right here, I see I have something right here at -3. I have a point right here at -2. I should have 2 of them there, don't I? And I have I have 2 points right there at 1. Erase my extra points I just put on there. All right, then your range is going to be your y's. And so remember, we're looking at the y-axis. So I'm going to start at the bottom and come up, and I see I have a point on this line, which is at -3. I have a point on this line, which is at -2. I have a point on this line, which is at -1. Point on this line, which is when y is 0. And a point on this line, which is where y is 1. Remember, you're only looking at the y values there. And so there is our domain and range. Now, so let's talk about another way to find domain and range, okay? They didn't really give us a good example here, but it shows up in your assignment. So what if they give us an equation? So let's talk about that. And I'm just going to use the space over here, okay? So if they give us an equation, domain is always all real numbers and less. Okay, so you have to check and see, does it fit one of these restrictions? The first restriction is what we saw here. Is it a list of ordered pairs? So if we have ordered pairs, and if we do, we're just going to list the x values. Second restriction is a fraction. If I have a fraction with x on bottom, okay, you're going to set the denominator not equal to 0 and solve. Those numbers will be the numbers that it cannot be. You need to tell me, though, where it is. So, for example, if we come out with x cannot equal 3, then that means your domain would be -infinity to 3, and then from 3 to infinity, okay? Notice the 3 would have a parenthesis because it's not equal to it. And then the third restriction is if it's an even root radical. So if it's an even root radical, we're going to set that radical greater than or equal to 0. So a quick little example would be like if I had the square root of x minus 2, if I'm trying to find the domain of it, I'm going to set that greater than or equal to 0. We'd have to square both sides to get rid of the radical. So add the 2. I'm out of rooms. I'm not going to show the +2, but I would add the 2, and I would get x is greater than or equal to 2. Therefore, that means that my domain would start at 2, and it's equal to, and it would get bigger because x is greater than that 2, so it would go up to infinity. All right, so there's the restriction. So remember, if they give you an equation, it's all real numbers unless it fits one of those 3 restrictions. All right, so let's keep going. Example 5 says identify the domain of each of the following functions. Then use a graphing calculator to verify your findings. So let's look at A. A, the first thing I'm going to do is try to put this into y equals. So tell me, though, first real quick, is this a function? It's not a function. And how do we know that? because we have a y squared, okay? And I forgot to mention when we were talking about functions, and it had to be where it goes into y equals, the two things to watch out for to make it not a function is if you have a y squared or you have an absolute value of y, okay? Y squared and absolute value of y, when you solve them, will not give you a function. So watch out for those. All right, so we know this isn't going to be a function, but let's go ahead and let's solve for y. So negative y squared equals 9 minus x squared. Divide everything by that negative 1, or you could multiply by negative 1. And so y squared equals, I'm going to switch these, so it's going to be x squared minus 9. Take the square root. So y equals plus or minus the square root of x squared minus 9. Now, this is not a circle because a circle has a negative x squared and a positive number inside of it, okay? This is actually what they call a hyperbola. And you were supposed to study this probably like in Algebra 2, but usually we kind of don't get to it, okay? So let's just use our calculator to help us some, or let's just build a table, okay? So I'm going to pick some values here to plug into my table. So let's put this in our calculator and pull up the table. All right, so don't forget, because it does have the plus or minus, you're going to have to use y1 and y2. And if you want to hit the graph button so you can kind of see what it looks like, you can. So in the end, it's going to kind of look like two parabolas here with some space in between them, and they're turned sideways going outwards, okay? So when I go back to my table, I can see that over here, these are going to be some negative x's. So I'm going to go to my table, and I see I have the point negative 5, 4. I'm sorry, negative 4. And I have the point negative 3, 0. I'm looking at y1 now because I'm working on that there. And then if I keep going, I see I have the point 3, 0. And I also have the point 5, negative 4. This is for my y1, which is where I put my negative in. Oh, my calculator just died. And it cleared itself. All right, so then let's go into the y2 there. Let me put mine back in because my calculator died and then came back on and cleared everything. All right, so when I go here and I look in that table, now remember that's this part of the graph, okay? So you can see it's over... It's over some more. Actually, I lied there. I lied when I told you the parts. I'm sorry. The first one, y1, did the bottoms here, not the left side. And so y2 is going to do these top pieces, okay? So you're going to have to look for your x's and your y's on the positive, or your x's on the positive and the negative side. And so I can see I have negative 5, positive 4, negative... I'm sorry. Did I type that in wrong? I'm getting this. No, that's right. Negative 3, 0. I have 3, 0. And I have 5, 4. Sorry, my calculator going off through me there. All right, and then we can plot those points. So negative 5, negative 4. Negative 3, 0, 3, 0, and 5, negative 4. And so we can see this is that bottom part of the graph. And if you go to your calculator and you hit graph, you see it graphs it first, okay? And then we have negative 5, positive 4, negative 3, 0, already have graphed, 3, 0, already have graphed, and then 5, positive 4. And so if you watched it when your calculator graphed it, there's your top part. That one's on the wrong thing. There we go. All right, and so that's our hyperbola. Now it asks us, what is the domain? Well, this one's not a function, so we can't use that all real numbers except, okay? So look at this one. What would our domain be? Remember, domain is your x's. And so as I look at this graph, it does keep going to the left. So I know it's going to go from negative infinity, but it doesn't keep going to the right. It's got this space here in the middle. So it means I'm going to have two parts of this because there's two parts to this graph. So that first piece, the one on the left there, keeps going to negative infinity, which is what we put here. And it stops right here when x is -3. Is it equal to the -3? Yeah, it's got a closed circle there, so it's included. And then we're going to do this little union. It looks kind of like a horseshoe. It's like a U, but don't draw the line down, okay? It's not really a U. And then we're going to jump over to this other part. Well, it starts right here at 3, and then it keeps going to positive infinity. And so there is our domain for that function. All right, let's go on to B. I'm going to clear that so it's not so messy looking. All right, B says we're going to do x squared plus 4x. So let's build ourselves a little table here. It's already solved for y, because remember, f of x is the same thing as y. So this is y equals already. And so we get x squared. And so we know this is quadratic, if you remember. So we know, and it's a positive quadratic, so I'm expecting to see something like this. So anytime you have a quadratic, you want to make sure that you include that vertex, okay? So I need to know where that point is. So if I just look at my calculator, it looks like it's a -2 something. So when I do my table, I need to make sure I put that vertex right here in the middle. So I'm going to go to my table and look, and I'm just looking at my y values. And so I can see that it looks like the lowest point is -2, -4. So even if that's not my vertex, it's that lowest point, so I know it's very close to the vertex. And this one it actually is. And so then I pull a couple other ordered pairs. So -4, 0, -3, -3. Then I got -1, -3, and 0, 0. And so I know for sure this is the vertex because these two share the same y values, and the next ones over share the same y values, okay? So let's plot our points. And then let's look at the domain. Now I can look at this two ways because this is a function. I can look at the rules. So the rules, remember I told you, is if you're looking at an equation, then check and see. We know it's going to be all real numbers unless. Is that a list of ordered pairs? No, it's an equation. All right. The second one, is it a fraction? No, it's x squared plus 4x. That's not a fraction. And the last restriction was, is it an even root radical? Well, this one doesn't have a radical at all in it. So that means that our domain is going to be all real numbers. Now, if I have the graph, I can also look at the graph and see that. I can see my graph keeps going to the left, my graph keeps going to the right, and there are no holes or anything in the rest of the graph, no jumps, anything like that. So therefore, everything was included, so all real numbers. Oops, I don't know why I wrote it out as all real numbers, because we do everything in interval notation. So remember, that would mean that all real numbers goes from negative infinity to positive infinity. We always write our domain in interval notation unless they tell us otherwise, okay? All right, so let's look at C. See, we can pull some ordered pairs off and graph it, but for time reasons, I'm going to go ahead and just skip the graphing right now. But I really want us to focus on the domain here. Why is my pen not turning off? There we go. All right, so look at C. How would I find the domain? Well, this is a fraction. So we know that our domain, that's one of the restrictions. So that means that the denominator cannot equal 0. So we have x squared minus 4 cannot equal 0. And so this is a difference of squares, so I could factor it, or I can go ahead and add the 4. So x squared cannot equal 4. Take the square root, so remember that means x cannot equal plus or minus 2. So if you think about a number line here, if it can't equal negative 2 and it can't equal positive 2, that means it can equal everything except them, right? So my domain would actually be then from negative infinity up to but not including the negative 2, union negative 2 up to the positive 2, neither one included, union 2 all the way to then the positive infinity. And so just so you know, if you go to graph this, you'll notice on your table that negative 2 and positive 2 have an error. And that's because those are those vertical asymptotes, all right? So we graph vertical asymptotes by drawing in dashed lines. And then you could have picked some points, but didn't really have any really good points. So when you go to graph this, first, real quick, as I'm about to type this in my calculator, it just reminded me, when you go to type this in your calculator, do you see how this has more than one thing in the denominator? So you have to put that in parentheses, okay? Otherwise, it's going to give you the wrong graph. Because your calculator is really smart. It knows PEMDAS. And so if you write it just like this or type it in just like that, it says, oh, division comes before subtraction, so I need to divide that first. But the way it's written says, we're going to take that x squared and subtract 4, and then we're going to divide x by that answer. So you have to tell it that the x squared minus 4 are together. It doesn't know it if you don't tell it. All right, and so when you graph this, when you look at your ordered pairs, you don't really have any good ordered pairs over here. I think you got like negative 3 and negative 0.6. And then in between here, you don't really have any good ordered pairs other than 0, 0. And then on the right side here, you don't have any good ordered pairs. I think it's like negative 3 and 0.6 or something like that. And so I'm not so worried about the graphing piece of it too much because you can follow the calculator until we get to where we actually talk about graphing the rational functions. And don't worry, that's coming up soon. So that's what our graph would look like. But the reason I went ahead and looked at the graph is because you can see on this graph we have 1, 2, 3 parts to it, okay? And so we have to have those 3 parts in our domain. So watch for that. And then D. It says h of x equals, so therefore it's already in y equals form, the square root of 3 minus 4x. Well, when we're looking at that domain, remember, this is a function, so therefore we can say it's all real numbers unless it's one of those restrictions. So is this a group of ordered pairs? It is not. Is it a fraction? It is not. Is it an even root radical? That it is. So remember, we said you're going to take the radical and set it greater than or equal to 0 and solve. So we're going to take the square root of 3 minus 4x, and we're going to set that greater than or equal to 0. Well, we can square this, and so we get 3 minus 4x greater than or equal to 0. Subtract the 3. So negative 4x is greater than or equal to 0. Negative 3. Divide by the negative 4. Now be careful, because remember, when you divide by a negative, you're going to flip that sign, okay? And so you get x is less than or equal to 3/4. And so then what we're going to do there is x is less than or equal to 3/4. When you look at your domain, less than 3/4 means it's going to go all the way to negative infinity. And it's going to go up to the 3/4. And is it equal to the 3/4? Yes, it is, because it says greater than less than or equal to. And so therefore, there is our domain. All right, and again, we could take and we could get some ordered pairs and graph this. And there's really not too many pretty ones that you could graph it, and so you would see that it looks something like this, okay? But it's going to come over more than we're actually looking at our table because it goes to that 3/4. All right, and then let's look at some applications here. Uh-oh, sorry about that. I don't know what is going on here. Nope. I've hit something. Let me pause this while I do work on this. Okay, so now for the applications. Example 6 is Terry's a sales clerk at Electronics Depot who earns $275 base pay plus $15 for each item sold. Express her gross salary G as a function of the number X of items sold. Find her gross pay if she sells 12 items. So first thing it wants us to do is find the gross salary G as a function of X. So G as a function of X. That means X is going to be my variable inside. But let's make sure we understand what the variables represent. So G, it shows us here is the gross salary, is a function of the number X of items sold. So X is the number of items that is sold, okay? So let's find that gross salary. How much does she earn? Well, it says that earns $275 plus $15 for each item sold. All right, so we got the $275 plus $15 for each. That means we're going to multiply that times the number of items that she sells, which in this case is just X. So there's our equation. And then it tells us to find her gross salary, or excuse me, find her gross pay if she sells 12 items. So that's saying, hey, find G when X is 12. So we're going to find G of 12. So we're just going to plug in that 12. So 275 plus 15 times 12. I'm just going to type that in my calculator. Now, G of 12 is notation, guys. Don't try to divide by 12, okay? It's notation. It's like f of x, g of x. Don't touch it. And so when I plug this in my calculator, when we give our answer, we should always label. And so we're talking about gross pay, so it's going to be money. And I got $455. All right, example 7 says, if your pre-calculus book is dropped from a height of 25 meters on the planet Newton, its height in meters after t seconds is approximately h of t equals 25 minus 12t squared. How long does it take for the book to hit the surface of the planet? So they gave us an equation here, and when they give us an equation, we have to make sure we know what those variables represent, okay? So, what does the h represent? Well, it says its height after t seconds is approximately this. So the height equals, so h is going to be our height, and we got to know what t is. Well, it said after t seconds, so t must be time in seconds, okay? So it says how long, that tells me we're looking for t, does it take for the book to hit the surface of the planet? Well, they didn't give me the height directly. They didn't say, hey, the height is this. But think about it. If it's hitting the surface of the planet, hitting the surface, how high is it off the planet? Well, it's not off the planet. It's on it. So its height would be 0. So we're going to let the height be 0, and we're going to solve for t. All right, so I'm going to add that 12t squared. I'm going to write that up here. So I got 12t squared equals 25. I'm going to divide by 12. And so t squared equals 25 over 12. And take the square root. So t is equal to plus or minus. And guys, we could work on finding the square root of 25 over 12. But honestly, is that going to make any sense to us? as far as the problem goes? Probably not. So it's okay on the word problems to do decimal approximations. So I plug the square root of 25 over 12 in my calculator. Remember, you're taking the square root, so it's plus or minus. And the square root of 25 over 12, it told me is 1.443. Okay, so we're going to round to 3 decimal places every time unless it tells us otherwise. And so let's think about that. This is time in seconds. Do our answers make sense? Well, yes and no. Time can't be negative, so the negative answer in this case won't work. So we end up with t is equal to the positive 1.443, and then remember to label. So we're talking about time, which is in seconds. So we get 1.443 seconds approximately. All right, guys, and so that's the end of 1.1. And so make sure you finish your assignment, and then we're going to start 1.2.